Okay, so right now we're going through our section C, which we've seen and talked about. That our section C would be for the non-right angled triangles. Okay, non-right angled triangles. They will have no right angle. Okay, once you see a triangle that doesn't have a right angle, then you know you are in section C. Okay, forgot to put the C. You know you are in section C, which means you are either going to use the sine rule or the cosine rule. So let's go through the things. Case one, the easiest case to see is the cosine rule case. Okay, cosine rule. Let's see. When we use the cosine rule, you'll be looking for either a side or an angle. Now, when do we use the cosine rule? We use it in two cases. One is when you have included angle, or the other one, it is when you have all three sides. All three sides of a non-right angled triangle. So you have a triangle with no right angle. And either it will give you an included angle, which is something I'm about to show you right now, or you get all three sides. Then you're going to use the cosine rule. And I'm going to show you how to use it. So let's first see the two cases. Let's first see two examples of a question that you can see. These triangles have no right angle. Okay. Now, if you get something like this is 7, this is 5, and this is 30 degrees. And then we call this A, B, C. And a question says, find side BC. Okay. If a question gives you this and it says, find side BC, can you see something? Here we have what we call an included angle. An included angle is an angle that is sitting inside two sides that you know. It is included. We know this side is 7. We know this side is 5. So these two sides that we know are making this angle here. So an included angle is an angle that is sitting in between two sides that you know. So this angle 30 degrees is sitting inside 7 and 5. So that is an included angle. If you were to get something, say this is 7, this is 30, and this is like 6, then they say this is A, B, C, and they say find side AC. This is not a cosine rule question. See, you've gotten 7, 6, 30. There is no included angle here. Because if you see 34, 30 to be included, we were supposed to know this side and also this one. Okay? So because we don't know this side, then we know that 30 is not an included angle. So we can't use the cosine rule and say we have an included angle because we don't. So now let's fix it. Let's see the other case where we use the cosine rule, which is when you get all three sides. So this one is easy. 7, 6, 8, whatever. Okay, ABC. This is a cosine rule question. If they ask for an angle inside, find angle theta, whatever they want. Once you get all three sides, then you're going to use the cosine rule. And what does the cosine rule say? So the cosine rule will be looking for, like in this case, they said find side BC, which is this side. The side opposite your included angle. Okay? They'll ask you for the side opposite your included angle. Or they'll ask you for the included angle itself. So now what you always do is, let's do for this guy. The side opposite the included angle, what you must know how to do for this section C. We saw in section B that Pythagoras looks for the hypotenuse. And we saw that SOHCAHTOA we need to know all the three sides. The opposite, the hypotenuse, and the adjacent. Now, for this section C, for both the sine rule and the cosine rule, you need to know how we label our triangles. Okay? You get a triangle, whatever the shape, we don't care. I'm making it even uglier now. We don't care. So this is not a right angle triangle. So now you get this as A, this vertex as B, and this as C. So this corner, when it's alone, is called a vertex. And then all three or two of them, when it's more than one, we'll call them vertices. Okay? So a vertex or the vertices, they get capital letters because they'll be representing some angle here. Okay, so this angle here could be called angle ABC, and we'll put a cap over B to say the angle is at vertex B. It is sitting at B, and you go from A to B to C. So that's another way. Or they can say, please find the angle at B. We don't care. That is just meaning this angle right here at B. Now, when we are labeling our sides, like we say, the angles and the vertex, okay, the vertices which represent the angles, they get capital letters, and then the sides get small letters. So small letters, that means you have a side, and the side would be opposite your angle. So opposite angle A is going to be, we go opposite, this is going to be the side small a. Opposite B here, this is going to be the side small b. And then opposite C there, this is going to be the side small c. Once you have labeled your triangle, then you can start applying the rules. So now that I've labeled, let's go back to the other one and let's label together. Easy. Opposite A here is small a. Opposite B down there is going to be small b. And then opposite C is going to be small c. So we have it like that. Now the cosine rule is looking for this angle. We use it when we get an included angle, and they're looking for this guy opposite the included angle. That's the one we can find. The guy opposite the included angle, and that's A. So we'll say A squared, okay? We start with it as an A squared. It is going to be equal to the other two sides, which is B and C. So B squared plus C squared, okay? We add them once they're squared. Then we say minus, then 2 of BC, then cos capital A. Remember that there will be a 2 in front of the BC. So since you said B squared plus C squared, they come back again. The B and the C, because they're the ones which you'll be knowing. They come back again. They're no longer squared here. It's just 2 of them. So minus 2BC, these guys which you had put here, they come again here. Okay, it's going to be BC. Then cos capital A, which is the angle of this guy, this small a that you're looking for. Okay, and you are going to get, I'll show you how to then use this formula in the videos where we answer questions. So just want you to know the cosine rule for now. You get your included angle, and that's what you do. Okay, so let's change these letters. Let's call them, sorry for that. Let's call them X, Y, Z. And let's see how I do for this one. This is X, this is Y, this is Z. How would I do this one? Well, basically, opposite capital X is small x. Opposite capital Z, if you go there, is going to be small z. Opposite capital Y is small y. Now, the side which you're looking for is the included angle, which is going to be at X. It is an included angle. You have been given all 3 sides. So we are looking for this included angle at X because we know this, we know the other one. So that's the one we are looking for. Now, how do we get them? All you're going to do is we use the letter opposite that guy. So that's small x. So we're going to say x squared is equal to the other 2 guys, which is y and z. So y squared plus z squared, then minus 2yz, then cos capital X. Cos capital X. Now, since we're looking for capital X, we're going to take this whole thing, which is part of the capital X. It's written together. 2y squared, 2yz cos x. It's one thing. We take it to the other side to make it positive. So it's going to be x squared plus 2yz cos x is equal to y squared plus z squared. Then we take x squared to the other side. You have 2yz cos x is equal to y squared plus z squared minus x squared. Then we'll take 2yz to the other side. We'll get cos x is equal to y squared plus z squared minus x squared over 2yz. Okay, then now when it's like this, we can always find our x. We can calculate this first and then take cos to the other side. We have cos being equal to x being equal to cos inverse of the answer you get here. Y squared plus z squared minus x squared over 2yz. You get a solution. That'll be your x, the angle, and you are done. Okay, that's how you're going to get it. That's how you're going to get the angle. So we've seen how to use it to get the a. For a, we'll calculate, and then at the end, we'll do square root of everything so that we'll get it as just the a. Don't forget to do that at the end, okay? Now, we are going to talk about the sine rule in the next video. Bye for now.